Okay, hello everyone, welcome to SSGB's Mentora. In this lecture, we are going to continue some important examples for the Z transform. In the previous lecture, we have already seen what is the exact formula for the Z transform and how to solve the basic fundamental examples using that formula. Now, let us discuss some more examples which are more interesting and might be asked in the university exams. Okay, so let's take one example. Let's say x of n. See that x of n is equals to 3 into 3 to the power n minus 4 into 2 to the power n u of n. This u of n unit step is most important in the Z transform because with the help of u of n that Z transform becomes the one-sided and it's easy to solve. So most of the exams prefer to this type of examples which are kind of easy to solve है ना. तो अगर हम डिस्कस करें we know the original form that if we are having a raised to n u of n, its z transform is z upon z minus a with ROC z greater than a. ये हमें पता है. अब क्या करते हैं कि इसी को रेफरेंस लेके ये एग्जाम्पल हम सॉल्व करेंगे. कैसे? कि अगर मेरे पास इसको ही हम अलग अलग कर दे थोड़ा सा, लाइक 3 into 3 to the power n u of n minus 4 into 2 to the power n u of n. तो ये बराबर है, कोई गलत नहीं इसमें. नेक्स्ट, अगर यही टर्म हम कंसिडर करें, it's similar to this. This is the a of n un is the z upon z minus a. Similarly, 3 to the power n u of n and 2 to the power n u of n. These are the multiples, simple multiples. Okay, so 3 will be as it is. Then we can simply write is z upon z minus 3. This is the a, this is z upon z minus 3 minus 4 into z upon z minus 2. Okay, I hope this part is clear. Now let's discuss the ROC side by side because this is the most important. Because once we solve the example, it's not needed that the always the one part only should be correct. The important second part is also important, that ROC should be correct. Like if I get the correct answer but if I written the ROC wrong, the whole example will be wrong. Okay, so this is the 3 to the power n u of n a. So for this part, ROC Z will be greater than a. What is a? It's 3. Okay, and for the second part, this 2 to the power n is there. Z is greater than 2. Okay, let's solve this completely and then we will again discuss about the ROC. Now this is simply what 3z upon z minus 3 minus 4z upon z minus 2. This is x of z. We can also simplify further, but I hope and up to this part if you are written, it's more than sufficient. Now let's discuss about the ROC. What ROC is telling that our z must be greater than 3 and must be greater than 2. But if you draw a timeline, if at this point I am having 2 and at this point I am having 3, ROC is greater than 3. So the Z, all the values which are greater than 2 but which are greater than 3 are also greater than 2. Values which are greater than 3 are also greater than 2. Therefore, my final ROC will be this. Means if I draw a simple circle, I hope this is visible. Okay, let's take the another color. If I draw a simple circle like this and it will be having, let's say this is the 2 and this is the 3, the ROC will be Z greater than 3 ultimately. Okay, this is the ROC, region of convergence. This will be the final ROC, Z greater than 3. This will be the final ROC for the given example. What is it? The 3 into 3 to the power n minus 4 into 2 to the power n u of n. And this is the kind of final algebraic expression. Or we can also simplify that the z square or some another term will be there, and after simplifying you can also write. Okay, for this example we will try to solve it. Let's try to simplify it further. Now it's a 3z z minus 2 minus 4z z minus 3. Okay, upon z minus 2 and z minus 3. Okay, now this will be 3z square minus 2z. Okay, now let's discuss one more important example. Let's say I am having some kind of value with me. Okay, so the example is x of n is equals to 1 by 2 raised to n u of n, 1 by 2 raised to n u of n plus minus 1 by 3 raised to n u of n, minus 1 by 2 minus 1 by 3 raised to n u of n. This example is given. So it's very simple that if a raised to n u of n is given, we can simply write it as the z upon z minus a. So by just watching this example, I can write that z upon z minus z upon z minus 1 by 2 here plus z upon z minus, and this is the minus 1 by 3. Okay, this is minus 1 by 3. So this will be my expression. Simplifying further, that z upon z minus 1 by 2 plus z upon z plus 1 by 3. This will be the x of z. What is this? X of z. Now talking about ROC, what it will be? ROC for the Z is greater than 1 by 2. This is the first part ROC. And for the second part, ROC is Z greater than, what is it? Minus 1 by 3. Okay. Now you will get to understand that why this mod sign is important. Under the mod, a negative number becomes positive. So ultimately Z is greater than 1 by 3. Now, if I draw a simple circle, okay, let's draw a circle. And for that, I am having the it's 1 by 2 means zero point 0.5, and it's 1 by 3 means 0.33. Let's say 0.33 is here, and this is the zero point 0.5, zero point 0.5. Ultimately, zero point 0.5 is greater than 0.33, and this z is greater than 1 by 3. And if we consider this, that z is greater than zero point 0.5, ultimately it will be greater than 0.33. So the ROC will be this z greater than zero point 0.5, the outside of the circle. This is the ROC. This is the most important because we will not write just the ROC for the different part. Ultimately, our example is single example. We need to write a single ROC. We can't say that the z is greater than 1 by 2, z is greater than minus 1. We can say, but if you apply the logic, z is ultimately greater than 1 by 2 because 1 by 2 is greater than the 0.33, 1 by 3. Okay, so these are some examples. We can also solve multiple examples, but I guess all the examples are kind of same kind of examples. We will also discuss some more part, like if I am having u of n, because next part is based on the inverse z transform. Our next lecture will be on inverse z transform. So we need to understand this kind of term. If u of n is given, its z transform will be z upon z minus 1. Okay. Now, if a to the power n u of n is given, then its z transform will be z upon z minus a. If I am having delta n is the given, then its z transform will be 1. Okay. Then some another function, let's say delta n minus 1 is given. If delta n minus 1 is given, if delta n minus 1 is given, then it will be z inverse, or ultimately we can say that n minus k is there, it will be z minus k. This is the z inverse. So this is the important part. For as kind of summary, we can understand that if u of n, various n type of signals, the time domain signals are given, its z transform will be like this. This is the x of n, and this is the x of z. At the start of next lecture, we will again discuss this part, because we need to understand the inverse Z transform. Up till now, we have discussed the examples on Z transform, also the various uh, techniques for the solving the Z transform. In the next lecture, we will see the inverse Z transform. Thank you.